Alright, so we're going to be focusing on scatter plots. Today we're going to make scatter plots by hand. Next week we'll be making them with technology. So bring your Chromebook. I know they've said that, but I haven't used them, so I have no clue if you guys actually have them. But we will be using the Chromebook, or if you have a graphing calculator and you want to learn how to do it on the graphing calculator, I can show you. So just make sure you bring those next week, please. But today we're just going to make our scatter plots by hand. So just a couple definitions first. So if you have one variable that explains or even causes the change in the other variables, the independent variable is known as the explanatory variable because it attempts to explain the observed outcomes. And then the dependent variable is known as the response variable, which those terms we used in the last unit. And response is because it measures an outcome of the study. So really quick, I'm going to have you guys, I have 6 random students' GPAs and ACT scores. Which one, GPA or ACT, is the explanatory variable and which one's the response? So I'll let you guys write your thoughts or draw a picture. Which one's explanatory, which one's response? GPA or ACT? All right, so Emma, which one's explanatory? Excuse me. And that means response is ACT. So in the first unit last term, where we spent a lot of time graphing on histograms and stem and leaf and box and whisker, and I feel like I'm forgetting one, dot plots. That was all when we looked at a single variable. So this will be the first time we're looking at 2 variable data. And the first thing you should do is start with a graph. And then you're going to look for an overall pattern. And any deviations from that pattern. And then we're going to add a numerical summary. And then describe the overall pattern. That means words. So today we're going to focus on the first 2. Next week we'll start adding all the different numbers that are associated with scatter plots. And I guess when I say look for an overall pattern, we are going to describe it today. So I guess we're focusing on 1, 2, and 4, if I'm being honest. So we're going to make a scatter plot of the GPA ACT data. In your homework tonight, I think you have to do 15 points by hand. Next week, I think we have around 30 to 50 points. I try to keep it lower than 30 even for technology because that's a lot of typing. So we know GPAs on the X, ACT scores on the Y, and then remember from Unit 1, we should start at 0 in the corner. So GPA unweighted goes up to a 4.0. So I'm going to go up to 4.0, which means halfway is 2.0. And halfway there would be 1 and 3. Oh man, I didn't go halfway between 2 and 4. It's closer to 4 than 2, sorry. And then I'm going to put all my like 0.5s, so 0.5, 1.5, 2.5, 3.5. I'm going to put the little hash marks for all the different decimals between 3 and 4, but not for the rest, because all our GPAs are between 3.0 and 4.0. And then I believe the highest ACT score is a 36, but for the ease of making my graph, I'm going to go all the way to 40. And then that makes it easy to just keep cutting things in half like we did with GPA. 35, 15, 25, 35. And then let's see. We'll do our hash marks from 15 on. 16, 17, 18, 19. Because since we're doing it by hand, we're going to estimate anyways. But the hash marks kind of help you estimate. Alright, so first data point is 3.019. So we'll say around there. 3.5, 27. 3.1, 22. 4.0 and 31. 3.7 and 26. And then 3.1 and 19. So, filling in the blanks below our scatter plot. A scatter plot shows the relationship between two quantitative variables. Quantitative. And those two quantitative variables have to be measured on the same individuals. And then each individual is on the as a point. 40 variable always goes on X, and response always goes on Y. If two individuals have the same data point, use two different symbols. What I do when that happens is I'll make, because I use dots as my symbols, so I would make a dot for the first individual with that set of data, and then I would circle it to let myself know that there are two pieces of data at the same spot. I haven't played with Google Sheets a huge amount where I had two pieces of data at the same point. I know that the graphing calculator, the default, I believe, is to use X's, and so that it'll have an X, and then it'll just kind of stagger an X right below it. So you can see it's two things, but they don't like separate them. So, and then we'll figure out how Google Sheets does it. And then if you want to add a categorical variable to a scatter plot, such as gender, you would use two different symbols. So let's say we wanted to include gender with our GPA, I almost said SAT, excuse me, ACT data. And so we could say that X means male and dot means female. And then Obviously, it doesn't say which ones, but you would have that information, and then you would, make your data points. And of course, females have the highest ones up there. So that is a way to add a categorical variable to your scatter plot. And then, like I said, when we look at a scatter plot, we want to look for that overall pattern. And there are a few things that we want to focus on with that pattern. The first one is direction. The second one is form. And the last one is strength. So with direction, we have two adjectives. Is that a describing word? Is adjective describing a word? That's a description word, right? I should never try to use English. Gosh. So there are two ways that we describe direction. If we say the two variables are positively associated, if above average values of one variable goes with above average values of the other variable. And my example there is the number of hours studied and test scores. Because in theory, if you increase how long you study, your test scores should go up. Obviously, I think there's a breaking point where you study too much and it's not beneficial anymore. So hours studied goes up, test score goes up. And then two variables are negatively associated when above average values of one goes with below average values of the other. My example, I love this example. As the temperature outside increases, so it gets hot outside, hot cocoa sales go down. So nobody drinks hot cocoa in the heat. So temp outside increases, hot cocoa sales go down. Yesterday I had a student, he was like, I'm just going to go buy hot cocoa when it's hot out and I'll just prove you wrong. Go right ahead. Yeah, that's going to increase our sales, right? So then form, there are three common forms when it comes to scatter plots. The first one is linear, which is going to be the focus of this unit. Then there's curved, which we will focus more on next unit. And then the last one is cluster, which I'll throw examples at you that are clustered, but we're not going to really focus on cluster ones. And then, of course, there's the exception where it's not any of those forms. And then strength. Strength is determined by how close the points in the scatter plot resemble a simple form. The form we're going to focus on this unit is a line. So if we look at our scatter plot up here, these points, they resemble a line pretty closely. So we would say that it's a pretty strong correlation. For now, you're just going to estimate strength. So like I said, it looks pretty strong because our dots are pretty close to the line I drew. I can see it's making a line, not a curve, and it's not just random dots, which would make it a cluster. Next week, we'll actually learn how to find the number that measures the strength of the relationship. But for now, you're just going to estimate and use your safety words, like fairly strong. And obviously, if it's not strong, it's weak. That's the opposite. And then, of course, we always have to watch out for outliers. And in Unit 1, the things you had to use to describe your graph made socks. This doesn't make much, so I call it DOFs. Direction, outlier, form, strength. I do like the idea of, I keep throwing it around in my head of doing soft D. I don't know why it sounds like a rapper name to me. Did you listen to Soft D too? But I've used DOFs for years, so that's what we're going with, because honestly, I'll probably forget Soft D. But socks is so cool because it's like a word, so you remember it. And this, I suppose we could say, I mean, if we did it this way, we could say foods. I mean, it obviously doesn't say foods, but at least then it's a word instead of DOFs or Soft D, the rapper. Anyways, moving on. There's no other, like, you can't put the S first. Sfad, like, I don't know. DOFs is what I originally started doing this because direction, form, strength, it's in order, and I just threw the O in there to make it a word, but I don't know. Now I'm like second guessing myself. I really am leaning towards Soft D. I could dress up as a rapper in the future and be like, Soft D. When I learned logarithms in high school, my teacher dressed up as a logger and handed out Tootsie Rolls because they're little logs. I hate Tootsie Rolls. They're disgusting.
I only like the vanilla ones.
But, so, you guys were awesome. You watched this video yesterday. We're going to just sketch, and that means it's not going to be accurate, but we're going to sketch the scatter plot of the boat registration and the manatee deaths so that we can describe it using DOFs.
Is that real data?
Yeah, it is real data.
That's so sad.
It is sad, isn't it? Yeah, manatees are an interesting creature. They're weird looking too. So across the bottom we have boat registration because the boat registration explains the manatee deaths. And the boat registration was in thousands, if you remember, or I put it in here. And I think if we go, because it goes over 1,000, so let's go to 1,100 and then go by hundreds. And like I said, we're just sketching it, so it doesn't have to be perfect. 4, 5, 6, 7, 8, 9, 10. 500, 100, and then, excuse me, the response is manatee deaths. And I think the closest, we got upwards towards 100, but we never broke 100. So we'll go to 100 there. And then that's 50, 10, 20, 30, 40, 60, 70, 80, 90. Excuse me. So like I said, this is not going to be, I'm not actually going to go through and graph the real data. I'm just going to make a sketch of what it looks like. So it started somewhere around here, and then it just went up. And it was pretty tight together. It didn't, none of the data points veered from that shape very far. So like I said, we're going to describe what we see. So that means DOFs. And just like with socks, we're just going to put the letters and answer them kind of like I think of it as a bulleted list. So direction, that's either positive or negative, and since we're focusing on linear shaped scatter plots, really you're thinking about slope. So does that line have a positive or a negative slope? It has a positive slope, so we would say this is positively associated or just a positive association. And then with outliers, like I said, the actual data, it stays pretty tight together. So we're going to say that there aren't any. If we had an outlier, you would notice it'd be a point that's pretty decently away from the line. So it would either be and we'll talk about this later in the unit, an outlier in the y direction or an outlier in the x direction. So in this case, because those aren't real points from the data, we're going to say that outliers are unlikely. Again, just like with the first unit, we're not going to say it for sure because it could be that one of those points is an outlier, but it's unlikely. Form, we can see that it takes a linear form. And then strength stays pretty close to that line that I drew. So we're going to say fairly strong. Like I said, next week we'll learn how to find an actual numerical value for strength. And then we can really get into very strong, just strong, not strong, weak, really weak. So, have to sometimes just identify your explanatory and response, kind of like I threw at you in the warm-up. Which one do you think explains the other? So first one, for student hours studied and test scores. Since I used that as my example for a positive association, I kind of gave it away. I said as the hours studied increases, test scores go up. So the test scores are the response, which means that the hours studied is explanatory. And then 2, for a given high school, college-bound students and teacher pay. Which one do you guys think explains the other? Or which one do you think is the response to the other?
Teacher pay will go up if college, there's more. The more college-bound people, the higher the pay.
So you think teacher pay is the response to college-bound students? You both think so? That actually, some districts do merit pay. And so teachers get paid more depending on whether their students are successful or not. And so college-bound students could be a measure of success. So you could argue that this one's explanatory, and this one, teacher pays the response. I did have some kids who argued the other way, and I had to agree with them. They had a good argument. They said that the more teachers are paid, the better, in theory, you're going to get better teachers to apply. And so the students should be more successful. So I would say that this one, there are arguments for it to go either way. My first thought when I read it was merit pay, which I am so glad we do not have. As a teacher, I'm not a fan of it. Because some teachers get to teach all upper level classes. And then, like last year, I had the Algebra 1B classes. Some of those kids just didn't care. They just came because they had to attend school, but they didn't care about passing no matter what I did. So I'm glad we don't have merit pay here. And then for a high school student, SAT math score and SAT verbal score. So which one explains which one? Or which one responds to which one? I like Chloe's furrowed brow. She's like, what? I would agree.
Yeah, that's what I was thinking.
So it was hidden in there. It says if applicable. So sometimes they're not going to be applicable, not applicable. I don't know if there's an actual correlation between those. I might have to dig up some data. I would think that there would be a correlation and that there would be outliers of kids who are really good at math and really not good at verbal stuff. That was me. And then the kids who are really good with language and suck at math. But I would think they should be, right, I would think if you're good at math, you should be fairly good at verbal. Or if you suck at math, you probably suck at, kind of like either you're good in school or you suck at school. And then what's our acronym? Just to hopefully drive it home. What's the acronym we used? SOFT. Soft D. Yes. Yes, soft D. Sorry. I really am thinking about changing it for next year. That blue doesn't show up well. We'll use this one. Soft D. And dress up as a rapper. Like with my chains. My baggy pants.
Yeah.
Do rappers wear baggy pants anymore? They did back when I was little.
mean, yeah.
Right? And
Well,
then,
like when I imagine that kind of like soft D, I feel
yeah.
like big jeans with
Yeah.
like your boxers and like
And the
jeans
belt
around here.
the belt
The
that
really
holds your
big
pants
belt.
around your legs, and you
Yeah.
have to walk like this so your pants don't fall down. Yeah. It's what I pictured too.
Yes, exactly. And like a big
Oh,
gold chain.
And then with a
that
D
turns like
on
this.
it. Because
Yeah.
I'm soft D.
Yeah.
Yeah. Yeah. I'm so doing it next year. All right. So
Yeah.
what do our letters stand for?
F stands for form.
F does stand for form. Yes, we got one.
S stands for strength.
S is strength. Okay, close.
That one word that's like
Outliers.
yes.
And
I'm glad,
direction.
I'm glad that Emma could read your mind on that one.
Yeah, she got me. She's got me. I knew all the words, but they weren't coming to my head. Like it's like when something's like so.
It's on the
Say
tip
it
of your
right now,
tongue.
on the spot.
Yeah.
I always have to start with the short words. I don't know why.
Form is short, and then the rest are like the same number of letters, aren't they? Direction might be longer. Yeah, direction's longer by one.
Yep.
All right, so that's it.